Hello students, welcome. Today Form 1, we want to do topic 2, that's chemistry of symbol classification of substances, lesson 1. Let's start first of all defining classification. What's classification? Classification is the process of grouping together substances with similar properties. Next, let's see, we said in Form 1, Chapter 1, matter is found either pure substance or a mixture. So what's a pure substance? So a pure substance is one that contains only one type of matter. For example, if you have only maize is a pure substance because it's made up of one type of matter. Next, let's go and see mixture. Mixture is the combination of two or more substances mixed together, and in which the individual components forming the mixture retains their physical and also chemical properties. For example, if we have maize and beans, so that will be a mixture if we mix them together. So we're saying several techniques or methods are available for separating the components of mixtures. The choice of the techniques or methods depends on three factors. The first factor is the type of the mixture. We have to know the type of mixture. Number two, the physical properties of the components of the mixture. Number three, which component or components of the mixture one is interested in. Those are the three factors that we are going to consider when choosing a method of separating a certain mixture. So we're saying a mixture can be separated by physical means, such as the use of magnets, baking or hand baking, winnowing. We have sieving, filtering, decanting, evaporating, and etc. So next we are saying categories or types of mixtures. So we have 6 types of mixtures or 6 categories of mixtures. One is solid mixtures. Number 2, solid liquid mixtures, solid gas mixtures, liquid mixtures, liquid gas mixtures, and also gas mixtures. But in Form 1, we are going to deal with only 3 types of mixtures, which are in bolds. Solid mixtures, solid liquid mixtures, and liquid mixtures will be discussed in details. So let's start with the first one. So we start with solid mixtures. Examples of solid mixtures include maize and beans, sulfur and iron filling, sodium chloride and iodine. So let us see again separation of solid mixtures. We are saying the methods of separating solid mixtures include the following: winnowing, baking, use of magnets, and also sublimation. Next, let's go to the descriptions on how solid mixtures are separated. Number 1, we start sulfur border and iron fillings. Let's start with the appearance of both sulfur and also iron filling. We are told iron is a gray solid, while sulfur is a yellow border. That's the appearance of sulfur and iron filling. So what is the color of the mixture? We are told the color of the mixture is gray-yellow. So next, a mixture of iron and sulfur can be separated by use of a magnet. So which property made or make iron fillings and sulfur to be separated? We are told the property that makes iron and sulfur to be separated is that iron is magnetic. That means iron gets attracted to the magnet, while sulfur is non-magnetic. That means sulfur cannot attract or cannot get attracted to the magnet. Okay, next let's go to the description on how a mixture of iron fillings and sulfur be separated. So during the exam you can be told describe how a mixture of iron filling and sulfur can be separated. Then you are given 2 marks. So I saying place the mixture of iron fillings and sulfur on a white paper, on a plain paper, and spread them out. Then hold a magnet above the mixture, the gray iron fillings gets attracted by the magnet or to the magnet, leaving the yellow sulfur border on the white paper. That's how we are going to describe. Lastly, let's see the application of the use of magnets. It's applied in industries such as iron recycling, glass recycling, and flour mills in order to remove iron particles. That's the application for this method of separating mixtures. That's the use of magnets. Next, let's see example 2. That's sodium chloride and also iodine. That's another example of again solid mixture. So I say sodium is a white crystals while iodine is a shiny dark crystals or shiny dark gray crystals. The color of the mixture is white and shiny black crystals. A mixture of sodium chloride and iodine can be separated by sublimation. So, if we can separate them by sublimation method, what property makes the two to be separated? We are saying the property that makes sodium chloride and iodine to be separated is that iodine sublimes while sodium chloride does not sublime. So what is sublimation? So sublimation is the process where a substance changes from solid directly to a gas or to vapor without underpassing or undergoing through the liquid state. So during the exam, you can be told define sublimation or what is meant by the term sublimation. So let's see examples of substance that sublimes. They include iodine, which we have seen in this example, anhydrous iron 3 chloride or anhydrous iron 2 chloride, aluminum chloride, we have benzoic acid, and we also have solid carbon dioxide, which is in other words known as dry ice. So during the exam, you can be told apart from iodine, state 3 other substances that sublimes. So you can talk about anhydrous iron 2 chloride or anhydrous iron 3 chloride, aluminum chloride, benzoic acid, and also solid carbon dioxide or dry ice. So I say a solid that sublimes can be easily separated from a mixture with another solid or solids that do not sublime. For example, in our case, if you are having sodium chloride and iodine, you can separate iodine because iodine is a substance or is a solid that sublime. You can easily separate from a mixture or with another solid like sodium chloride which does not sublime or that do not sublime. Okay, let's see lastly the description on how a mixture of sodium chloride and iodine be separated. So I'm going to say place the mixture of sodium chloride and iodine crystals in a beaker covered with watch glass. Then the watch glass contains ice cooled water, containing ice cooled water, full stop. Then we have to heat the beaker. We have to heat the beaker. Then iodine crystals sublimes. What does that mean? That means it changes from solid directly to vapor, and it's deposited on the cooler part of the watch glass, or it is deposited beneath the watch glass, leaving sodium chloride in the beaker. And that description, we can check it here. This diagram, we are having the heating here. This is the tribal stand. This is the wire gauge inside. Then this is the beaker. It's covered with cool water in a watch glass. So the mixture of sodium chloride and iodine crystals are heated. Then what will happen is iodine vapor is formed, or iodine sublimes. It sublimes. Then when it changes to gas or vapor, this ice cool water, their role is they condense or they change the vapor, iodine vapor, back to solid iodine, and they will be deposited beneath the watch glass or on the cooler part of the watch glass, like that. So you are going to have your iodine solid or iodine crystals there. Then sodium chloride will remain in the beaker. So let's see next. Lastly, let's see application of sublimation method. We are saying it is used one for purification of substances like iodine by separating it from solid impurities that do not sublime. Like for example, if you are having a mixture of iodine and maybe sodium chloride, and we want pure iodine, we can just do sublimation method. Then number 2, we are saying dry ice is used in cool boxes by ice cream vendors. So we are saying next, those are the application of sublimation method. Advantages of dry ice over ordinary ice. We are saying dry ice sublimes, leaving no wetness, and it's also a better coolant compared to the ordinary ice. So we have two advantages of dry ice over ordinary ice. One, dry ice sublimes, leaving no wetness. Number 2, it's also a better coolant compared to the ordinary ice. That's the end of our video today. Thank you.